Hi guys, and welcome to Science in 5. In this video we're going to talk about how to add vectors in 2 dimensions. But before we get to the actual calculation itself, let us learn another important skill: how to draw the direction of the resultants. To draw the direction of the resultant, we're going to look at 2 methods: the tail to head method and the parallelogram method. Let's start with the tail to head method. Suppose 2 learners push a desk as follows. Learner 1 applies a force of 80 newtons north. Learner 2 applies a force of 60 newtons east, as shown in the diagram below. For us to determine the direction of the resultant of these 2 forces, we're going to need to manipulate this diagram. So we're going to remove the object, the table, and replace it with a dot. And this dot is going to be the origin of a system of axes. So you might as well put in the east or the positive x, and then place in the north or the positive y-axis. Now the next thing we want to do is to make sure that these force vectors have their tails touching the object from the origin. We are now drawing the forces as pulling forces. Once we've got the forces as pulling forces, we can now actually slide one of the forces along the other force such that its tail touches the head of the other force vector. Once this happens, we can actually draw in the resultant from the tail of one of the vectors to the head of the other vector, like that. Alternatively, we can move or slide the horizontal vector such that its tail now touches the head of the north vector, like that. Then we can easily draw in the resultant like that. So that is how you can perform the tail to head method. The next method we can talk about is the parallelogram method. Once we've got your force vectors or your vectors with their tails starting from the origin, we draw in parallel sides to each of the vectors. So you can see there's a parallel side to the north, to the vector going in the north. There's a parallel side to the vector going in the east. The resultant is now from the 2 tails to the 2 heads, like that. So that is how you can perform those 2 methods, the tail to head method or the parallelogram method, to determine the direction of the resultant vector. We want to determine the direction of the resultant vector in these 3 diagrams. Let's start with diagram 1. We notice that in diagram 1, the force vectors or the vectors have got their heads touching the origin, like that. We would rather have these force vectors with their tails starting from the origin. So how do we then manipulate this diagram to make sure that these force vectors have their tails touching the diagram? We can extend the line of action of each vector and then slide each vector along its line of action, like that. So now the vectors are acting with their tails starting from the origin. And the next thing we can do, draw in the parallel sides to each of the force vectors. And then once we've drawn in the parallel sides, the resultant will be from the 2 tails to where the heads meet, like that. We have determined the direction of the resultant vector. In this case, we are not yet concerned with the magnitude yet. We're just concerned with how to determine the direction of the resultant. It's a very important skill. We will need the skill in the next video. Diagram 2, we already have got the force vectors with their tails touching the origin. Notice I'm using the word force vectors, but these methods work for any kind of vector. Okay, so now With these vectors drawn in like this, all we need to do is to add in the parallel sides. Once we've got the parallel sides, the resultant will be from the two tails to the two heads like that. We've managed to draw in the resultant. So anytime you've got a system of two vectors, you can use the tail to head method or the parallelogram method to draw in the resultant vector. In the last diagram, it seems the vectors have already been drawn head to tail. We might as well just draw in the resultant like that. And we are correct to do that because the resultant vector is always from the tail to the head like that. But this can easily complicate this diagram because for us to determine the direction of this yellow vector, the resultant, we now need to measure its direction from the tail. Remember, the direction of a vector is always measured from its tail. So which means we need to add in an axis at the tail of this vector like that. Okay. But if you don't want to do that, well, you can slide this vector that has got its head touching the origin such that it also becomes drawn as its tail coming from the origin like that. Once the vector is drawn as a pulling vector, we can now draw in the parallel sides. Once we place in the parallel sides, we can easily draw in the result. There you go, guys. That's how you can use the tail to head method or the parallelogram method to determine the direction of the resultant vector. We've got one more example to do. In this example, we've got 4 vectors. Question is, what can be correctly deduced from this diagram? Do you think you can be able to work this or solve this problem quickly? If you can, pause the video, solve the problem, and see if your answer agrees with us. If not, let's discuss why and why not. Okay, so we've got 4 vectors on this diagram: vector A, vector B, vector C, and vector D. What can be correctly deduced from this diagram? Well, we are told that vector A is the sum of vector B, vector C, and vector D. If this is the case, then we should be able to see these vectors drawn head to tail. We should be able to see vector B, vector C, and vector D drawn head to tail, and vector A starting from the tail of vector B, ending at the head of vector D. Let's see if that's the case. So here is vector A. Vector A is not starting from the tail of vector B. It's actually starting from the head of vector D. It's between a head and a head. So vector A cannot be the resultant of any vectors. Okay, because it's starting from the head and it's ending at the head. We know that the resultant will start from the tail of one vector and end at the head of the one vector. Let's try out option B. Option B says vector B is the resultant of those 3 vectors. Okay. If we look at vector B is starting from the tail of one of the vectors and is ending at the head of the one vector. So this makes sense. Vector B looks like it's the sum of vector A plus vector C and vector D. One way of seeing if this is correct is just to imagine that these vectors are displacement vectors. Okay, you're making a displacement. You're moving in a specific direction from a starting point. So if this is the starting point, you can move along vector C, you can move along vector D, then you move along vector A, you stop at this position. What will be the shortest route you can take from your start point to your finishing point? Well, it looks like that will be vector B. So vector B can be the resultant displacement of vector C, D, and A. So vector B is actually the resultant of all the other 3 vectors. If we look at option C and D, we can disqualify the notion that vector C is the resultant of the other 3 vectors. Look at vector C. it's starting from the tail of one vector, ending at the tail of the other vector. So vector C cannot be the resultant of the other vectors. Vector D starts from the head of one vector and ends at the tail of the other vector. Again, it cannot be the resultant because we say the resultant always starts from the tail of one vector to the head of one vector. So there you go, guys. That is how you can use this idea of determining the direction of vectors drawn on a diagram. If there are more than one vector, if there's more than one vector in your diagram, it becomes easier to use the head to tail method. Draw the vectors head to tail, and then the resultant will be from the one tail to the head, like a displacement. But if there are two vectors, it seems the parallelogram method might be the easier method to use. I don't know what you guys think. Let us know in the comments below. So guys, that is it for now. In the next video, we're going to talk about the actual calculation of determining the magnitude and the direction of the resultant vector. I hope you guys enjoyed this video. So we'll see you guys next time. Share this video, subscribe, add a comment, add a like. It will help us promote this video. Thanks for watching. See you guys next time.